Everyone, Saidu here. Welcome to another CCNA Cyber Ops Lab. Now, quickly, previously I put out some videos on how to capture and analyze TCP packet and UDP packet using Wireshark. But in this video, I want to use Wireshark to capture and analyze UDP header, which is like what we did before. But in this video, I would like to use TFTP, for example, the trivia file transfer protocol between two computers in the mininet topology. So let's get started. Now, the first thing to do is obviously going to start the mininet topology using this command sudo lab.support.file/script /cyberops underscore py. So this will start the mininet topology, but I have to enter the password of analyst, which is cyberops. And then from the mininet prompt, I would like to start two hosts at the same time. If you remember, I usually start one host using this command extam, then the name of the host or the host name. But in this one, I want to join them together and start them at the same time. So extam h1 h2. So this will start the host 2 or will give me the prompt shell for both hosts. Now from the host 1, I would like to start a script here using this command /home /analyst lab.support.files/script /start tftpd.sh. Now, after entering that, I would like to create a file for TFTP transfer between the hosts. Now, while I am still in the h1 prompt, so I will just create a text file using this command. I'll simply enter echo, then double quote. This file contains my TFTP data. So actually, this is supposed to be the content of the text file. Then I'll close the quote. Then I'll use this greater than sign to refer it to the destination or to the path that I want to save this particular text file, which is srv/tftp slash my underscore tftp underscore data. Now, to verify that the file has been created with the desired data in the folder, simply cut it out using this command cat/srv/tftp slash my tftp or my underscore tftp underscore data. So here, this is the content of the text file, which is this file contains my tftp data. Now, something to note about this TFTP, the security measure for this particular server, the name of the receiving file needs to exist already on H2. In order to solve this mystery or to solve this problem, I will just create a, a simple name file or a file named my underscore TFTP underscore data. So I'll head over to my H2, my command prompt here, and then use this command touch space my underscore tftp underscore data. All right, that is it. I'm done with h2. So now I'll come back to my h1 to start the tftp or start the Wireshark. Now, right from the prompt, I will enter the command Wireshark -gtk. Now, after the window have opened, I will go straight to the edit menu, choose preferences, and click the arrow to expand the protocols. Then scroll down and select UDP, which is a very long scrolling. You have to scroll down to select the UDP, and then now click the validate the UDP checksum if possible to just simply check the box and click apply and then click OK. All right, that has been done. So I will now start a Wireshark capture on the interface of H1, which is ETH or ETH0 interface. Now I'll go back to my H2 host and start a TFTP session. Now I'll go back to my H2 to start the TFTP session to the TFTP server on H1 and get the file my underscore TFTP underscore data. So right from the prompt here, I'll enter the command TFTP space the IP address, which is 10.0.0.11 space -c and then space get. Use this command get or keyword get space my tftp underscore data. Now, after issuing that, I will quickly stop the Wireshark capture And then I'll set the filter to TFTP and click apply or click here or hit enter from your keyboard. Now these are the TFTP packet or these are the TFTP capture right from the Wireshark window. Now, but detailed UDP information is available in the Wireshark packet details pane. So highlighting the first UDP datagram from the host computer, and I'll just move the mouse pointer to the packet details pane. So it might be necessary to adjust the packet details pane and expand the UDP record by clicking the protocol expand box to have more view of the entire thing or the entire information there. Now, the expanded UDP datagram should look similar to what I'm having here on my screen. You have your source port, you have your destination port, you have the length, also the checksum. So that is the UDP header. So if you scroll down, you find a trivia file and transfer protocol. So if you expand down there, you also get to see other information like the source file and the opcode, which is the read request, for example. Now, from the first UDP datagram, we can actually get a lot of information. One is we get to know the source IP address, which is supposed to be the H2, the IP address of the H2 or the host 2. Then we get to know the destination IP address, which is our server. And then we'll get to see the source port number, which is randomly generated number, and then the destination port number, which is port 69 here. So we even get to see the UDP message length, which is this, and then the checksum. Now, a checksum is sent in the UDP datagram, and the datagram checksum value is recomputed upon receipt. So, if the computed checksum is identical to the sent checksum, then the UDP datagram is assumed to be complete. So, this is kind of in reverse when examining the first frame returned from the TFTP server, which is now from the host 1 back to host 2. It's kind of reversed because the IP address will be reversed and even the length might change from this example. So you see now the source IP address is this, the destination IP address is that, then the source port number, destination port number, and the UDP message length. So what is interesting here is the checksum. So another thing to pay attention to is the return UDP datagram. So here the return UDP datagram has a different UDP source port number, but this source port is used for the remainder of the TFTP transfer. The reason being because there is no reliable connection, only the original source port used to begin the TFTP session is used to maintain the TFTP transfer. So another interesting fact or another interesting thing to note from this example is that the checksum or the UDP checksum is incorrect. So this is most likely caused by UDP checksum offload. Now you can learn about this UDP checksum offload online by just searching the UDP checksum offload. All right, that is it, guys, and I hope you learned something from this. And this is just the basic on how to capture and analyze a UDP traffic. It's somehow the same with TFTP, but in this example, I try to take things further to just use maybe a TFTP application to test out this kind of traffic. So analyzing it is straightforward, it's easy. Just select the first datagram or the first UDP datagram there, come back to your details pane, and then click down the arrow and check the information that you want to check. So, all right, that is it, guys. From this, and I'll catch you in the next one. But before then, I will just quickly clean up this lab here using this command or using this step first from the terminal. From the mininet terminal, I'll just enter quit to quit all the topology or end the mininet topology. Now at the prompt there, I'll enter the sudo space mn space dash c to clean up the processes started by mininet. So thank you for watching, and I will see you in the next one.